Hello everyone. Thanks for my YouTube video. This is Dr. Song. So after 2 weeks, it's a very long time. I was absent and then I have been somewhere. So now I'm back. So I will now start our quantitative research method course. So today will be the last session of the week 4. So we were looking for the so many descriptive statistics until now. And today is the last session about the reliability analysis. So that is called the Cronbach alpha. So we will talk about that. And then first, I want to tell you about my courses are constructed based on the three courses. These courses were given in the University of Ottawa in Canada. So three professors' name and then their course name. So the reliability analysis, Cronbach alpha, is a measure of the how well scale items are intercorrelated. So this shows the like proof of your constructed questions in the survey. They are intercorrelated. So that is the how you can provide the evidence about that. If items measure the same construct, they should be correlated with each other. Yeah, so if we want to measure about deception, for instance, and then you are all items, yeah, so scale items, that should measure the deception. In that case, they will show the high reliability. The correlation between the items is known as the inter-item correlation that examines the correlation coefficient between each item and the other items in the scale. So that is very much making sense. So you will see that in the we use the SPSS. So you will go to the analysis scale and then reliability analysis. And this is the way how you obtain the reliability Cronbach alpha. I will show you that. And then when you obtain the result, and then you can see the Cronbach alpha is that is the coefficient, and then how many items you have, and then you have the some descriptive statistics here. And then if you have this part is greater than zero point 0.9 is excellent Cronbach alpha, there is a good reliability. And then this is also the level of the good. Acceptable is zero point 0.7. So until here, if you obtain, that is fine. But if you have under acceptable, that is another good reliability. So you have to check your items. Maybe they are not exactly the measure of what you want to measure. So you have to verify about that. So when you obtain your output of SPSS, you can find that these are the items. If they are deleted, they show that so the item 7 and then 10. If they are deleted, the internal consistency will increase. So this means that item 7 and item 10 they are problematic. So maybe they don't measure the what you want to measure. So you will think about that by this column. Okay, and then you can see also the item 7, item 10. They shows the the internal consistency. So these other items is very poor, but this one and this one is good. So also this is the how you can detect they are not correlated in the between the items. So some mentions about the Cronbach alpha. If you delete the item 18 and the 8 and 7 here, so there's here the 7 and 10. So in that case, the Cronbach alpha will increase. In general, normally distributed data contributes the higher Cronbach alpha. Yeah. So if you are one item, so you have the many items like here, you have the 10 items, and then each item has is a continuous variable, so you can obtain the normal distribution or not. If they are normally distributed, and then they can give the also higher Cronbach alpha. To make it, if all items are well correlated and not redundant, we have to proceed with the factor analysis. So factor analysis, that is the mechanism. You can filter what is redundant or what is not correlated. So that this is another statistic analysis. You can proceed with if we want to make sure your scale variables are well correlated. But this one, it will be in another phase, not this time. So let's see about with the real example. So this is one example, empathetic listening scale. that is about the 11 items. But in fact, they have the subscale because the listening, empathetic listening, they have the three parts about the sensing, processing, and responding. But all of them together, they are the empathetic listening scale. Just they are like three parts of subscales. So in that case, you will obtain the 1, 2, 3, 4 first, the mean score, and then scale 2 is the processing, the three items mean score, and then the other 4 items mean score, and then you will obtain the Cronbach alpha of the each subscale. So all together, that is the empathetic listening scale. It happens not all the time, but the one scale variable has the 11 items, but they can have the subscales. So we will see about that. And the other one is that one relationship, a closeness scale, they have the 12 items. There is no subscale. However, you can see the asterisk here and then here and here. That means that this is number 2, 8, and then 12. They are negatively constructed, the question. So you have to reverse the order. So for instance, my relationship with my best friend is close. That is positively constructed. But look at the number 2. When we are apart, we do not miss my best friend a great deal. So that is negatively constructed. And then my best friend and I do not do a lot of things together. That is also negatively constructed. I do not consider my best friend when making important decisions. So this is also. So there are three items that should be reversed to make before making the mean score. So be careful about this. So you can calculate the internal consistency Cronbach alpha after reversing the order, and then when you obtain the coefficient of Cronbach alpha, if there is not a good way, not a good one, is under 0.7, you will exclude the problematic items, and then you will see how internal consistency changes. And then calculate the mean and the standard deviation of the each subscale or scale variable in the relationship, and then correlate closeness scale. So we can do this. Next time we will start the week 5 lessons. So this is the last one. So let's practice about this one. So this is, you can see that there are listening scale that is 11 until 11 items, and then closeness they have the 12 items. So let's do first the listening scale about the sensing and the processing, etc. So there is only 1, 2, 3. They are the one subscale. 4, 5, 6, 7 is a one subscale, and then 8, 9, 10, 11 that is a one subscale. So when you will do this different three subscales, you have to go to the transform and then compute the variables, and then you will put here is like how can I say that? It's a sensing. That is the one subscale name, and then you will put that is here is a mean. Yeah, mean score. You will do that, and then you will put the number. Listen 1 is there, and then this place is listen 2 there, and then listen 3 is there. So this is about the mean score of the one subscale, and then you say okay, and then you will see that in the end of our column, you have here sensing scale. That is about the only one part of the listening scale, and then you have the mean score. So with this mean score of the sensing, only 3 items, you will go to the analyze and then the scale and the reliability analysis. And you will put the 1, 2, 3 here, and then statistics. You will do the for the item scale correlation if you want, and scale if item deleted. Yeah, that is very important because you will find what makes your coefficient of Cronbach alpha weak. So that is, and then the continue, and then okay. So in the output, they generate the what you commanded, and what is most important is this. Reliability statistics is a 0.752. So this is the is a good level. I mean, that is acceptable. I mean, more than acceptable. It's a good level, so that is good. And now let's see about uh, here. If Cronbach alpha item deleted, so you can see that If number one, listen one is deleted, and then you will obtain the 0.802. So that is increased one than what you have now. So the others are okay, they are good one. But if the item listen one is deleted, you will have a better Cronbach alpha. So you will think about the listen one, because in fact that makes your Cronbach alpha is under 0.8. So this is the way how you find the problematic item. Okay, so that is, and then also I will show you how you can calculate about the reversed order. So when you see the reversed order was the number 2, and then number 8, and then number 12, that you have to construct as the normal order, like reverse the order. So you will see here is we will go to a transform, and then recode into different variables, and then you will put that is a number was let's do the only one item, so you will know. So that was the first one is number 2, so you will go to the we will go to number 2. So not the listening is closeness, number 2 is here. This should be reversed, so you will say that reversed, and then underscore close 2. Okay, and the label now you can put the space, reversed close 2. Okay, and then you change the name, and then all the new variables. Okay, so you will put the old value is a 7, and then they will go to the 1, and then the 6 will be the 2, and then the 5 will be the 3, and then the 4 will be 4. Okay, and then the 3 will be 5, and then 2 will be 6, and then 1 will be 7. So that is a reversed order. And now system missing, there is no system missing, but anyway you will add that. Yeah, and then everything is the same. So that will be continue, and then the okay. And then you can see that in the data view, you have that reverse the closeness too. So let's verify it that is reversed correctly. Is a number 5, and then reverse closeness is a 3. And then number 1 here before all the value, it becomes a 7. So they are reversed correctly. And now you have to use this column when you calculate the mean score of the closeness. So not only number 2, you have to get number 8, and then number 12 or exactly the same way. After reverse to that, your column will be reversed close to, reversed close to 8, reversed close to 12. And this should be calculated, not this one, and then this one. Okay, so that is about the reversed order. Okay, now I think that you understood how you can make the mean score of the scale variables, and also the how you can reverse the order also, and then how you can obtain the Cronbach alpha using the that what I showed you, the scale, and then the inter consistency. Uh, how can I say that the name is exactly the reliability analysis. So that is about the interconsistency analysis. So thank you so much for today. And then next time we will go further with the week 5 sessions. Thank you and see you next time.